Hello everyone, I'm Juvidia Kadir, roll number 23I6025, and this is our digital logic design project titled Motion Doorbell. Well, I worked on this project with Hooria Abbasi. We are students at FAST and UC's Islamabad. This project demonstrates how digital logic can be used to detect motion and trigger a buzzer automatically. This is a quick overview of the sections we will cover in this presentation. We will start with the project overview, explain the circuit, show the simulation, and conclude with our learnings and possible improvements. Well, introduction and overview of project. What is the project? Our project is a motion activated doorbell using an IR sensor and NAND gate. It detects motion, triggers a buzzer automatically. This replaces traditional doorbells and offers better convenience, especially for old people or disabled users like handicaps. What problems does it solve? It eliminates the need for manually pressing a doorbell, which can be hassle for handicaps or old people. And also it provides enhanced convenience, particularly for elders and disabled individuals, ensuring they can easily alert occupants. System level block diagram components used. So basically we used IR sensor, NAND gate, buzzer, power source. IR sensor is a motion detector. NAND gate 7400 IC buzzer acts as the output device to signal detection, power source, and a breadboard. Power source will provide the power supply to the circuit. So here we can see the block diagram of motion doorbell, like a person approaching. Then IR sensor will detect motion via IR reflection and output goes low. NAND gate circuit will invert low to high. One input is already at high. Buzzer activated by high signal at output of NAND gate, and then we can heard a audible alert. And it is also connected to the battery by ground and power supply. Working demonstration simulated demo steps. So basically here is a simulation snap in which we have used NAND gate, IR sensor, battery and buzzer. Step 1 is powering on the circuit to prepare for detection. Step 2, the IR sensor detects motion. And step 3, the NAND gate processes the input signal and determines the output. The buzzer is activated, producing a sound to alert occupants. This is the same steps followed in block diagram. So basically in this slide we are going to explain the working of our circuit. Here is the IR sensor, NAND gate, battery and a buzzer. IR sensor has 3 pins. One is grounded, other is the output which is connected to one input of the NAND gate, and the third pin is connected to the 9-volt battery which is VCC. So if we look at the mechanism of IR sensor is at the logic state 1 because it is connected to the 9-volt battery. But when it detects the motion, its voltage all drops to almost to 0, which makes its logic state to 1. And on the other hand, if we look at the NAND gate, its one input is connected to the 9-volt battery, other input is connected to the output of the IR sensor. So that means our NAND gate output totally depends on the IR sensor output. If IR sensor is at logic 1, that means it does not detect any motion. And this is at logic 1, this is at logic 1. Both pins are of input are at logic 1 of NAND gate. So at the output, it will invert the logic 1 to 0, and we did so at the buzzer will not ring. But if it detects motion, its voltage drop to 0, almost 0, and here at NAND gate we will receive 0 input, and that output it will inverse the input, and the logic state 0 converts to 1. So it will allow the current to pass through the buzzer, which will make the buzzer to ring. So in this way our motion doorbell work. If it detects the motion, it will ring. If it not detects the motion, it will not ring. So I did contributes in these things. I lead the project development, assembling the circuit and integration, assemble the circuit and simulation to demonstrate the working of the circuit, and develop the slides and the reports. So from the next slides, Hooria will explain the further things.
Real world applications. This project has multiple real world applications that demonstrate its practical relevance. Smart homes. This system can be integrated into smart home automation setups, offering enhanced control, convenience, and security. Automated entrances. It is suitable for use in business that require controlled access, allowing for automated entry and improved operational efficiency. Visitor detection. This system improves overall security by effectively detecting and managing visitors as they arrive. Further improvements. There are several ways in which this system can be improved for better performance and expanded features. Buzzer notification. By adding a timer counter, the buzzer sound duration can be extended to ensure clearer and more noticeable alerts. Microcontroller integration. Integrating a microcontroller like Arduino could open up possibilities for advanced features and better control of the system. Notification system. Implementing a notification system or integrating a camera would enhance security and provide real-time feedback to users. Conclusion and learnings. This project provided a strong learning experience in both theory and practical implementation. Sensor interactions. We learned how sensors interact with digital logic circuits, which is a key factor in success of such systems. NAND gates. We applied NAND gates in practical scenarios, understanding their importance in solving real-world logic design problems. Troubleshooting skills. We develop essential skills in troubleshooting and simulation, which are critical in electronic and circuit designs. Thank you.